Before we start this video, a large thank you to Vias, Limerence, and Enemir for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Halo Burner for their immense support to the channel this month on Patreon. It is greatly appreciated, my friend, and I hope you enjoy the video. Hello everybody, and today we're going to add the pursue target state. First I'm going to drag my AI script in the AI folder here, then I'm going to create a new script. I'm going to call that pursue target state. So as it suggests, we're just going to get the AI to follow the target. We're going to get a path using the Navmesh agent, but we're actually going to move with our animations. And it's going to be a little bit weird to set up, but we're going to go through it and I'll show you step by step. So I'm going to start by deleting the start and update functionality inside pursue target state. And I'm going to make this derived from the AI state. You need to put in a namespace or else I'll get an error. And now I'm just going to simply override the regular tick method. And we're going to start by basically commenting out what we want to do in this video. At least most of what we want to do in this video. So first thing we need to do is check if we're performing an action. So if the AI is like say attacking or they're doing some kind of dodge and they're in this state, then we don't want to move. We want to just wait until the action is over before we continue to apply any movement logic or try to get a path of any sort. Next, we're going to make another comment right below here, and I'm just going to say check if our target is null. And if the target is null, we just basically want to go back to the idle state because that's how we find our target. Okay, so if the target is null, we don't have a target, return to the idle state so we can then continue to look for a target. If we pass these two checks, next thing we're going to do is just make a comment here again, and we're going to say make sure our Navmesh agent is active. So if the Navmesh agent, oh I can't speak, is not active, then you're not going to be able to make a path using that agent. So we got to make sure that is active. We're going to actually put a Navmesh agent on our character soon. We'll get to all that. And then we're going to say if we are within combat range of a target, then we're going to switch our state to the combat stance state, which again doesn't exist yet. So this for now is just a comment. We'll do that one in the next video. If the target is not reachable and we are far away from home, we're going to return home. We'll do that one in a separate video as well. That's very easy to implement though. And then we're going to say pursue the target. Now there's multiple ways to do this, pursuing a target. I'm going to show you a couple ways, specifically on how to get a path. And we're going to do the pursuit using animations, specifically root motion animation, which is how Souls and Elden Ring handles it. So let's make an empty game object on our AI here called Navmesh Agent. It's very important this is an empty game object and it is a child of your main object. I'm going to add the Navmesh Agent component to this. And I'm going to go into the AI character manager and we're going to add a variable for this. And we're going to have to say using unityengine.ai. So I'm going to make the header Navmesh Agent, and then I'll put the variable here. Now, if you don't know what Navmesh Agents are, you should go watch a video on that. But basically, they're just little AI that are used to calculate paths to get to certain destinations. I'm greatly oversimplifying it. So if you're familiar with them, that's great. We can continue on. If you're not, I think you should do a little bit of a reading before you watch this video, or maybe watch a video on how they work. So I'm going to say using unityengine.ai up here at top, and then I'm going to put a public Navmesh Agent variable here. I'm going to call this Navmesh Agent. Okay, so I'm going to call that on awake. We're just going to say Navmesh Agent is equal to get component in children Navmesh Agent. Now, if you want to hide it in the inspector like we do with our other variable there so you can't see it, you can do that. I'm going to keep it visible here for now to make sure it's actually getting called correctly. Now, I am going to save that, and now we have our agent. Now, right below that, let's make a header for states, okay? So we have current state, which is the state that you're on right now, but let's actually make a header and a few variables for all the states we're going to give every AI. So the first one is going to be the idle state. Now you can call it idle or idle state, whatever you prefer, doesn't matter. I like using full names mostly. I avoid shorthand whenever possible, but sometimes it kind of fits the situation. So for now, I'm going to call this one idle, and I'll call the pursue target state pursue target. Now I'll make comments here for the next two states. We have combat stance state and attack state. And in the future, we'll also have investigate sound state, but we won't put that one there yet because that's kind of a very distant feature. So let's go down here on awake, and we're going to say idle is equal to instantiate idle. Now, why are we doing this? Remember, this is going to be a scriptable object, and if you edit a scriptable object, it edits universally across the project. So you always want to use a clone when using scriptable objects. It's just a good practice. So pursue target state is equal to instantiate pursue target, and I'm just going to say here, make a comment so we know while we're doing this, use a copy of the scriptable object so the original is not modified. This again is just a very good practice when working with scriptable objects. So I'm going to do it here as well. Okay, so we can save that now, and right below here we can say current state is equal to idle state, and I'm going to take a sip of my coffee. Okay, cool. So now that we have the states and we're initializing the idle state, we can save that now. I'm just checking this over real quick. So you can make this public if you want. Actually, we're going to have to because we're going to reference this in other scripts in the future. You can use a getter and setter. Again, I know I always come back to this. I'm not using it at working alone. But if you're working with a team, it's always best to use getters and setters for this stuff so people don't accidentally take the wrong variable. It's a good practice to get into. Okay, so next over on the AI state, I am going to put in a public virtual state. So not a void, an AI state, sorry. And we're going to call this switch state. And every time we switch a state, we're going to call this function because it's going to run some logic that's going to be very important in the future. We're going to make it require an AI character manager variable. We'll call it AI character, and we'll make it require a new state to switch to. Now, why are we using this? Well, every time you switch a state, you may want to do other things. The biggest thing you want to do is reset any potential state flags. So for example, if you're keeping some data on your states and you need that to reset every time you switch out of the state and come back into it so it's refreshed and you can start the state over from a brand new slate, then you want to call this reset state flags. So let's make a protected virtual void called reset state flags. And we're going to make it by default so that every time we call switch state, before we switch to our new state, we're going to clear off any flags on the state that we're leaving. So for example, if you have, let's say, a flag on your pursue target state that says like, I've made it home if they're walking home, then when you leave that state, you can set that flag back to false. So when you come back into the state, it's not already set to true. So you're just like skipping some logic. And that's just a very simple example, but we're going to use this a lot in the future. For now, it's not going to do anything, but it will come into play very soon. So let's make sure we call reset state flags on switch state. And now let's go back over to the idle state here. And right here where it says we have a target, we can now use our new function for switching a state. So let's call return switch state. And then let's just pass the AI character, and then let's pass the AI character dot pursue target, as in the pursue target state. So now if we have a target, we're actually switching to that state that we just made. Otherwise, we're continuing to search for a target. I'm going to delete that debug message. Don't need that anymore. And I'm going to take a sip of coffee. Okay, let's create an asset menu here in the pursue target state. I'm going to call it AI/states/pursue target. Then we're going to need to make that in the project. Before we do that, though, I'm going to put debug.log up here, say pursue target, just to make sure we're actually switching state correctly. So then we can test that in game. Going to minimize it. Going to go over now. Going to create my new AI states pursue target state. And I'm going to put the idle and the pursue target state in the idle and the pursue target state variable slots here. All right, so I'm going to save that prefab now. And now we can go into the game, and I'm not getting a debug message, so I think I know what I did wrong. Whenever you're calling this function, make sure you use the return keyword. So switch state won't work. You have to say return switch state, and it's very nefarious because it won't give you any errors. So that's my bad. Now if I go back in game here, pursue target is definitely calling. You can see the debug message. Cool. So we know it's switching correctly. That's great. Let's move on to the next phase. So I'm going to get rid of the debug message and return base tick, and we're actually going to start putting in some logic now. So we can do the first one here. The first one is we're checking if we're performing an action. This one's very simple. If your AI character dot is performing an action, return this, which means just keep coming back to the state until it's done. And then you won't go any further and you won't run any logic below this. I'm going to keep that comment there actually, just so we know what this is for in the future if we come back and glance at this 6 months from now. If our target is null, if we don't have a target, return to the idle state. Very simple. We use our new function again. So if AI character dot AI character combat manager dot current target is null, we're going to return switch state past the AI character and the AI character dot idle state. Super simple, super straightforward. Okay, now make sure the Navmesh agent is active. If it is not, enable it. So that's pretty straightforward too. If AI character dot Navmesh agent dot enabled is false, then AI character dot Navmesh agent dot enabled is equal to true. I'm gonna take a sip of coffee. Okay, so we can skip the next one. If we're within combat range of a target, we don't do that in this video, so we'll just come back to that when we get to the combat stand state. If the target is not reachable and they are far away from home, yeah, we can skip this one too. That's a polish. We'll come back to that in a future video. Now, pursue the target. Okay, so there's two ways to do this, guys. I'll explain why. I'll explain why I use what option and what benefits each option have. So option one is we simply say AI character dot set or dot Navmesh agent, dot set destination, and we pass the AI character dot AI character combat manager dot current target dot transform dot position. So we pass the position of our current target. Why am I getting an error? Right, that's set destination, not set path. My bad. So this will run asynchronistically and basically update the destination of the Navmesh agent. Now option 2 is we go down here and we have to say first using UnityEngine.ai, sorry. Option 2 is we make a variable for a Navmesh path. Call that path. Initialize it as new Navmesh path. And then we say AI character dot Navmesh agent dot calculate path, and we pass the destination of our current target, and we pass the path that we just made, and then we say AI character dot Navmesh agent dot set path, and we pass the path. So as it stands, set destination is definitely more performant and it runs asynchronously, which means it'll calculate the path while stuff is happening. But now if you use calculate path instead, it's going to basically calculate the whole path immediately. And this can be costly if the path is very, very long and can potentially cause like a drop in frames. Now, I have anywhere between 6 and like 15 enemies on screen at a time in Nephilim, and I haven't noticed any drops yet. But I'm not calculating ridiculously long paths. I use option 2 because personally I found that if I used option 1, if the terrain or the path was weird, set destination just wouldn't work. I'm not entirely sure why, but I know others have had the same problem as me, so I encourage you to make an attempt to use both and see what works best with you. I'm going to stick to using option 2 because it's what I use in my project, and my project is what I'm basing much of the source code of this project off of. Okay, so with that out of the way, now, if you go to the scene here and try to actually start the game, you're going to see we get an error. It's going to say the Navmesh agent needs a Navmesh to calculate a path. So basically what we need to do is actually make some Navmesh so the agent can actually see where it wants to go. So to do this, if you're using anything before Unity 22 or 2022, go to Window, AI, Navigation, go to Bake, and then just click Bake. Now make sure your objects are static or else you won't be able to bake. So if I go to my construct here, like the floors, you have to make sure that the objects that you want the Navmesh on had this navigation static check mark here that I'm showcasing. Otherwise, it won't bake. So if you're using 2022, I'm going to quickly update against my better judgment here so I can show you what to do because it's probably going to be very buggy still. So yeah, here in 2022, you're going to see it's going to say navigation obsolete. You can see here it just says obsolete. So make an empty game object, call it Navmesh, and then I'm just going to close this tab here. Under Navmesh, I'm going to add a component called Navmesh Surface, and then just basically click Bake on top of this. And then you're going to see it's going to bake another additional layer. I'm actually going to go to the old one here, the obsolete one, and clear the bake so it doesn't have 2. There we go. And we're probably going to see some bugs because 2022 at the time of this video is kind of unstable for me. Very unstable, actually. So if you are using 2021, I'd recommend staying on it for a while. So if we go back into the scene here now, you can see there's no error. And if I actually move around with my player and highlight the AI, you can see the AI's Navmesh agent is definitely following me. So that's cool, working as intended, but the AI obviously isn't moving yet. We haven't given it any way to, but the agent is tracking me as is intended. So if we go now into the AI character net, oh, we actually don't have that script yet. Okay, let's make the AI character network manager script. And as you probably assume, it's going to derive from the character network manager script. So I'm just going to make that here. We can open it up, delete the start and update functionality as is per tradition, and make it derive from the character network manager script. There's some heavy duty trucks outside, so apologies if you hear any background noise. So I'm going to make this derive from the character network manager, and now we're going to go over here and just grab a random bool, anything really, because we're going to change it to suit our needs, and just paste it over here. And we're going to call this bool is moving. Now, we could just use this for the AI, but I was going to do this in the future video to not lay so much on you in a single video, but honestly, this is pretty straightforward. So we're actually going to move this to the character network manager in a moment because we're going to use this for the player as well. I'm going to show you what it does. So why do we need to keep track of if we're moving or not? Well, for the AI sake, it's pretty simple. When we're moving, we want to know if we're going to basically do some logic with the Navmesh agent or not. So right down here, we're going to say if Navmesh agent dot is enabled, we're going to get the agent's destination in a vector 3, and we're going to make that equal to the Navmesh agent's destination. So that's where they want to head, basically. And then we're going to make a float for remaining distance, and we're going to assign that distance as a vector 3 dot distance between the current position of this AI character. We're going to do that by saying transform dot position and the destination of where it needs to be. So then we're going to say if the remaining distance is greater than the Navmesh agent's stopping distance, we can set that up later in the Navmesh agent's component. Then we're going to say is moving is equal to true. And we're going to have to reference our AI character network manager first. So let's make a variable for that. Hide inspector, public AI character network manager. And on awake, we can call that by saying AI character network manager is equal to get component AI character network manager. So this assumes obviously that it sits in the same game object as your AI character manager, which is why we're using get component. So after we've done that, now we can go down here, we can just assign .isMoving to true. And I know this is a network variable, but don't worry, we're never going to run this logic, the state machine behaviors, if you're not the owner or the host. So you don't need to check for isOwner here. AI character network manager.isMoving.value is equal to true. Otherwise, we are not moving because we're either close enough to our stopping distance to stop moving. So then we'll say equals false. Now, if our Navmesh agent is not enabled, then isMoving should always be set to false. Okay, so that's why we need it for the AI, but there's a double reason here. So let's move this back to the character network manager. Now, you won't notice this problem yet, but trust me, I haven't. It was the bane of my existence for a while. If you start having certain kinds of animations on your override layer, and then when they're done, you go back to your locomotion layer, right? There's this weird stutter that happens. And I looked into it, and apparently with Unity, you're supposed to have a state separate for your idle states. So let's make a parameter on the animator called isMoving. And now let's create an empty state. Now you can make one for locomotion one-handed and two-handed, but we don't have two-handed yet, so you can just keep the state empty for that. Let's call this idle one-hand weapon, and then we'll have idle two-hand weapon. So basically in this blend tree, you're not supposed to have a stationary state. So says the Unity guidelines, and so I've been told. I'm not sure why, but you're supposed to only have the states full of moving logic. So right where we have idle, let's just replace that with walk forward. And then where we have our idle state now, we're actually going to put our idle animation here. And this will stop any weird stutter you may be getting when you're playing an override animation and coming back to the locomotion. I was having it in Nephilim for a while, didn't know why. This is the solution to it. So this is the way you're supposed to do it. Let's make a transition back to the locomotion state. We're going to make a condition if we are moving, then we're going to has exit times on true, snap back to movement instantly. And likewise, if we're not moving, snap back to the idle state instantly. So I'm going to say isMoving is equal to false, and that's it. So that's how you're supposed to handle it. Now this has a really great effect too for the AI since we're using a root motion. If we're not moving, then we're just going to go back to idle state and not move forward anymore. We're not going to play root motion animations. Now under handle player input over here, we can say if move amount does not equal 0, then we must be moving. If our vertical or horizontal is negative or positive, it's not 0, we have to be moving, else moving is equal to false. And now since we're using netcode, we can obviously use onValueChanged here, and we can update the animator automatically using that little call. So let's go over to the character manager. Let's use override on network spawn and on network despawn, and any class that inherits from this will get this logic called as well, as long as you're calling the base.onNetwork spawn and despawn. We're going to say character network manager dot isMoving dot onValueChanged plus equals character network manager dot on isMoving changed, and this doesn't exist yet, but we're going to make it right now. And likewise, let's make sure we remove this subscription to this function when we despawn the object as to not cause memory leaks. Okay, so now let's go and create a function for onIsMovingChanged. I'm just going to put it right below onIsChargingAttackChanged, and we're going to use a bool old status and bool new status, but honestly they don't matter because we're just going to reference directly the isMoving variable. So we're just going to simply say character.animator.setBool isMoving, and then we're going to pass the isMoving.value. Now remember, we're using root motion to move the AI, so it's going to go back to that idle state whenever you're not moving, which is whenever you get to your destination using the Navmesh agents, and it will stop moving forward automatically. So let's go to the AI character prefab and add your AI character network manager so we don't get an error in the inspector when we start this. And then let's just drag it up here on top where the old character network manager used to be. Let's go in the game, and now if I walk over, you can see, yep, they're definitely trying to move. So what's happening here is, let's just take a look. We go to the scene view and click on this this AI here. You can see the Navmesh agent is definitely at me, so it's getting the destination. And we click on the scene view here. I'm just going to drag it so you can see both. If we go over, you can see isMoving is true on the AI character network manager. And if I get close, nothing changes. If I change the stopping distance to 1, he stops. Change it back to 0, see he's still moving again. So stopping distance at 1, watch what happens if I walk away here. If I walk away, he starts moving again. So basically, when I'm more than 1 unit away, he's going to continue to move at me. And if I get close, you can see here, he's going to stop. But there's no movement actually happening. But if I tick use root motion, watch what happens. He's going to start moving towards me. So that's one part of the puzzle. But he's not really rotating towards me. He's not moving towards me in any capacity because he's not using the logic of the Navmesh agent. So let's create a new script called the AI Character Locomotion Manager. And we're going to direct the rotation of our AI here using the Navmesh agent's rotation in a very simple way. So let's delete the start and update functionality as is per traditional. Let's drop in a namespace. Mine's SG. I'm going to make this inherit from the Character Locomotion Manager. And we're going to use one simple function here that's very, very straightforward to cause this guy to rotate towards us. We're going to call this public void rotate towards agent because we're going to have other rotation logic here in the future for attacks and stuff. We're going to pass the AI character manager, AI character, and this is going to be primarily used in the pursue target state. So we're going to say if character.ai character network manager.isMoving.value, then we're going to simply say AI character.transform.rotation is equal to AI character.navmesh agent.transform.rotation. Okay, so we're going to save that. Now let's go over to the the pursue target state. And what we're going to do right below where we check if the Navmesh agent does enable, we're going to say AI character dot, and we need to call AI character locomotion manager. So let's make a variable for the AI character locomotion manager in our AI character manager script. And I'm going to hide it in inspector because I don't need to see it. I have faith that it's going to be called correctly. And we're going to say AI character locomotion manager under awake here. We're going to say AI character locomotion manager is equal to get component AI character locomotion manager. And I'm then going to go to my prefab and add that there and replace the regular character locomotion manager. Man, the autofill is not working in my favor here today. All right, there we go. Save. Okay, so let's save that. I'm just going to reorganize the awake method. And now I'm going to go back over to the pursue target state. I'm going to call AI character locomotion manager.rotate towards target. And we're going to pass our AI character. Now let's save that. Now, if you get the error in the inspector, that is a Unity 2022 thing. Don't worry about it. It's a netcode thing. Basically, if you can't see some of your netcode variables, just hit play and then exit play mode. Let's drag in our AI character locomotion manager here. And this error is really annoying. To my knowledge, it's supposed to be fixed in the next iteration of netcode for game objects. So you might not even have it by the time you watch this video. But it was not there on 2021. So if you haven't updated, I encourage you not to update yet. Next, let's go over to the ground layer. Also, this isn't working either. The tab is bugging out. The inspector is really bugging in 2022. Make sure you set your ground layer. Now, if we apply root motion, you can see he's kind of spazzing out. There's not much constructive that's happening here. But you can see the Navmesh agent is definitely trying to get to us. But he's not really walking the right direction. Now, if we reset the Navmesh agent's position every single frame, watch what happens. He gets really close to getting towards us because he's using the Navmesh agent's rotation, but then the position's coming back every single frame. So there is the solution to our problem. What we need to do on the process state machine, very important here, make sure you do this after you ticked the state. This needs to happen after, not before. Navmesh agent.transform.local position, as in the local position of the game object, is equal to vector 3.0. That brings it back to the position of the AI character. Likewise, Navmesh agent.transform.local rotation is equal to quaternion.identity. That resets its transform. So basically, every frame, the Navmesh agent is going to try to turn towards the destination on the path which it needs to go. You're going to copy that rotation, and it's going to reset the position and rotation back to 0, and the process will repeat infinitely, which will give you a character that is guided by the Navmesh agent, but is moving with root motion. So if we go back into the project now, check this out. I will tick apply root motion, and now he walks towards us. And now if I were to go into the game view here, I'll drag the scene view here so you can still see it's open. If I go to the game view here now, and I actually run around, he's not stopping because we don't have a stopping distance set up. So if you go to the Navmesh agent and you hit the stopping distance here to 1, he'll stop. And now, before we move on, actually, let's just set that up so we have to keep doing that. Let's go to our dummy. You probably already done this. If you haven't, go to your dummy or your character, tick apply root motion here, and then go to the Navmesh agent. And then what you want to do is just put the stopping distance to say 1. Could differ depending on the size of your character. Obviously, set it up to whatever you need to set it up to. Now, let's go back into the project here now, and I'm going to keep the scene view open so you can see. I'm going to start the game, go into low game, and now you can see the character is moving towards us. If we highlight him, watch what happens to the agent. It's always staying under the character, and if I run around, the agent follows. And if we get close, the agent stops. So there you go, guys. That is Navmesh movement. But also, you just basically take the destination of the agent, but you're moving the character with root motion. So you got that nice movement that's controlled by your animations and not by some just random number. It's a bit more difficult to set up, but I think for a Souls-like or an Elden Ring-like game, it's definitely necessary. And this is the same system I use inside my Project Nephilim. So we still have a few things to do. In the next video, we're going to add a pivot state. So basically, if you're not facing a target when you enter the state, you'll turn towards them first. It's a nice bit of polish. And also, we're going to talk about how to make AI character movement look nice on the network. Because right now, if you go to multiplayer and boot this up, you're going to see the AI character is going to be moving kind of slidey. And that's because the AI character is going to be fighting by syncing its transform in the network, but also by moving with root motion. And that's going to give you a very weird looking movement. So we're going to showcase how I basically smooth that out to make it look normal. And we're going to add a pivot. And then if we got time, we're going to jump into the combat stand state and start doing some logic there. So ladies and gentlemen, thank you very much for joining me here again this week. I hope you all have a very lovely weekend. And I will see you next week when we continue with our AI. The next couple of topics are going to be, again, some locomotion, and then the combat stand state, and then finally the attack state. And it is at that point you'll have a fully functioning AI. We can drop some into the scene and make a little mock-up level before we move on to making a boss. And as always, a genuine immense thank you to my Patreons. It's because of all of you lovely individuals I get to keep doing this, and I appreciate you all so much. All right, guys. See you later.